Hi everyone, in this video we are going to discuss about the theorem number 5 from geometry of circles. This theorem is mainly focused on the cyclic quadrilateral. Here the theorem says that in a cyclic quadrilateral, if one pair of opposite sides have the same length, the other pair of opposite sides are parallel. Here I have a diagram. There you see we have a circle having point O as the center, and I have drawn a cyclic quadrilateral there, ABCD, and AB is equal to CD. The length of AB is equal to the length of CD. If that is the case, then we have to prove that AD is parallel to BC. To do the proof, I have to do a little more construction. First, I am going to connect the points A, B, C and D with the center O. Now if you look at the two triangles, triangle OAB and triangle OCD. For these two triangles, you see OA is equal to OB is equal to OC is equal to OD because they are the radii of this circle. So OA is a radius, OB is also a radius, OC is also a radius and OD is also a radius. And also we have been provided that AB is equal to CD. That means the length of AB is equal to the length of CD. So between these two triangles we have an SSS criteria of congruence. So we can say that these two triangles are congruent triangles. And because they are congruent triangles, then the angle ODC will also be equal to angle OAB, that will be equal to angle OBA, and that will be equal to angle OCD, because each of these triangles also individually isosceles triangle. Since the two sides, the OA and OB, they are equal, similarly OC and OD, they are also equal. So the triangles are individually isosceles triangle and also they are congruent triangles. So those four angles will be equal, and let's call it alpha degree. Next, let's look at the triangle OAD. That is also another isosceles triangle because OA is equal to OD, which is nothing but the radius of the circle. So then the angle OAD will be equal to angle ODA, and let's call it theta degree. And similarly, if we look at the triangle OBC, that is also another isosceles triangle because OB is equal to OC, which is nothing but the radius of that circle. So that is an isosceles triangle. So angle OBC will be equal to angle OCB, and let's call it beta degree. Now from a previous theorem, we know that the sum of the opposite interior angles in a cyclic quadrilateral is equal to 180 degree. So I have noted here that angle D plus angle B is equal to 180 degree, and then in place of angle B, I am writing alpha plus beta. So we can say that angle D plus alpha plus beta is equal to 180 degree. And then in the next step, what I have done, in place of alpha plus beta, I have written angle C, because if you look at the diagram, angle C is also nothing but alpha plus beta. So angle B is essentially equal to angle C. So we can say that angle D plus angle C is equal to 180 degree. Now if you see, we have two lines AD and BC, and then if we consider CD as a transversal between these two lines, and you see the sum of the two interior angles there on the same side of the transversal, the angle D and the angle C, their sum is looking like 180 degree. That means AD must be parallel to BC, because we know from the properties of parallel lines that the sum of the two interior angles on the same side of the transversal between two parallel lines is equal to 180 degree. So in this case, since angle D plus angle C turns out to be 180 degree, we can claim that AD is parallel to BC. Now if you want to quickly see what that property is, I have a diagram here. I have AB parallel to CD, and then EF is the transversal. So then angle EGD plus angle DGH will be equal to 180 degree because that will be just one straight angle, and angle EGD has a corresponding angle which is GHB. So in place of EGD, I have written angle GHB, and then in place of DGH, I have kept it as is. So angle GHB plus angle DGH is equal to 180 degree, and that is the case when AB is parallel to CD. So you can see that the sum of the two interior angles on the same side of the transversal between two parallel lines is actually equal to 180 degree. So in the original proof, I have used this property that when the sum of the two interior angles on the same side of the transversal is equal to 180 degree, we can claim that the two lines are parallel. This brings us to the end of this video. I hope everything made sense. Thank you for watching. See you in the next video.